Hello, the book's name is Problems in General Physics by Irodov. We are going to solve question number 1.24 of this book. A radius vector of a point A relative to the origin varies with time small t as r vector is equal to a t I cap minus b t squared j cap, where a and b are positive constants and I cap and j cap are the unit vectors of the x and y axis. Find a part, the equation of the point's trajectory y as a function of x. Plot this function. B part, the time dependence of the velocity v vector and acceleration w vectors as well as of the moduli of these quantities. C part, the time dependence of the angle alpha between the vectors w and v. And D and the last part is the mean velocity vector averaged over the first t seconds of the motion and the modulus of this vector. Okay. So first, to deal with the A part. A part says the equation of the point's trajectory. We need to find y as a function of x. Okay. The first part is this. Now see, it's given in the question that r vector is equal to a t I cap minus b t squared j cap. But we know that in two dimensions, the position vector r vector of any point is actually written this way: x I cap plus y j cap. So if I compare the coefficients of I cap and j cap, what I get is the value of x turns out to be equal to at and the value of y will be equal to minus bt squared. Okay, so these are the values of x and y. So what we have found here is that this is x as a function of time and y is also represented as a function of time. So t is the parameter here. So now we need to eliminate t. If we eliminate t from these two equations, we will get y as a function of x. Okay, so I'm solving it here. See, it's x is equal to at, so this will imply that if I divide both sides by a, I'll get x over a is equal to t. Fine. So this is the value of t, and if I substitute this value of t in the second equation, that is the equation for y, I will get y is equal to minus b t squared. So this can be written as minus b and t squared, instead of t I will substitute x over a whole squared. So this will imply that y will become y is equal to minus b x squared divided by a squared. This is the answer to the first part. The equation of the point's trajectory y as a function of x. This is how you will get y as a function of x. The second part says is asking us to plot this function, and it is given in the question that a and b are positive constants. Okay, fine. So I'll continue from here. The same equation y is equal to minus bx squared over a squared can be written as y multiplied by a squared is equal to minus bx squared is equal to minus b x squared. Okay, now this can be written as y a squared plus bx squared is equal to 0. So this is an equation in terms of x and y, and the problem is we don't know the values of small a and small b. It's mentioned in the question that small a and b are positive constants. Okay, and we are supposed to draw a graph of it. So what we can do over here is we can take any two positive values for a and b and draw the graph accordingly. So what we can do is we can take we will take those values which will give us greatest mathematical easiness. So I am taking the value of a to be equal to 1, and I am taking the value of b also to be equal to 1. So this equation will then become y plus x squared is equal to 0. And we need to draw a graph of this equation. As you can see, this will be a parabola, because a parabola which will be opening in the downward direction. Okay, so actually I drew the graph of this using Desmos, and here's the graph. X squared plus y is equal to 0. This x squared plus y plus x squared is equal to 0. They're the same things. So if you draw the graph of it, you will get a parabola which is opening in the downward direction. So the A part is solved. Now let's see the B part. The B part says that the time dependence of the velocity v vector and acceleration w vectors as well as of the moduli of these quantities. Okay, so we need to find velocity vector and acceleration vector, and r vector is given in this fashion. Okay, r vector is equal to at I cap minus bt squared j cap. At I cap minus bt squared j cap. Okay, so first of all, in order to find velocity vector, we know that velocity vector can be written as dr vector by dt. This is the basic definition of the velocity vector. The velocity vector can be written as dr vector by dt, which means I'll just have to differentiate this equation with respect to time. So if I do that, I'll get r vector is equal to at I cap minus bt squared j cap. If I differentiate it, dr vector by dt, I'll get this will be d by dt, and a and I cap are constants, so they can be taken out of differentiation sign. So only t will get differentiated, and the differentiation of t with respect to t will be 1. So I'll just get a 1 over here. And similarly over here, you can see that b and j cap are constants, so they will be taken out of the differentiation sign, and this t squared needs to be differentiated with respect to t, so I'll get just a 2t over here. Okay, now dr vector by dt is equal to this much, but dr vector by dt is my velocity vector, so I can write v vector is equal to a I cap minus 2 b t j cap. So this is my velocity vector, and this is the answer to the first part of the problem of part B. Okay, now let's see. We need to find the acceleration vector, which in this notation, in the book's notation, they are calling it as w vector. However, in India there is a convention, we use a vector for that, but it doesn't matter. It doesn't matter because it's just a matter of notation. Let me use the same notation which the book is using. W vector, this is the acceleration vector, and acceleration vector we know is defined as dv vector by dt. Okay, this is dv vector by dt, so this will become d by dt of the velocity vector, and the velocity vector here is simply a I cap minus 2b t j cap, right? So if I differentiate this with respect to time, what the first term a I cap, the first term is a I cap, and that is no t over here, so both these terms are constants. The differentiation of the first part will simply become 0, and the second part, when I'll differentiate the second part, minus 2b j cap are constants, so only t will get differentiated, and the differentiation of t with respect to t is 1, so I'll just get a 1 over here. So my final answer for w vector will be minus 2b j cap. This is the answer. Okay, let's see. The time in B part they are asking the time dependence of the velocity v vector and acceleration w vectors as well as of the moduli of these quantities. So we also need to find the moduli of these quantities, which means that we have to find the modulus of v vector and modulus of w vector. Let's see. modulus of v vector. See, we know that modulus of any vector will be equal to, suppose I have a vector like this, a vector is equal to, let's say, x I cap plus y j cap, and we need to find the modulus of a vector. So the formula to calculate the modulus of a vector is the square root of x square plus y square, right? So in order to find the modulus of velocity vector, what we need to do is we just need to take the square root of both the x and y components. We need to square the x component and the y component, add them, and then take the square root of the result. So v vector is equal to a I cap minus 2bt j cap. So a square minus 2bt square, a square plus minus 2bt square. This is the modulus of the velocity vector, and this is equal to the square root of a squared plus 4b squared t squared. Okay, so this is the modulus of v vector. Now let's see modulus of w vector. It's easy to calculate modulus of w vector because there is no x component there. There is only a y component. So the modulus of w vector will be what? Modulus of w vector will be equal to the square root of the square of the x component, but the x component is 0, plus the square of the y component, and the y component here is equal to minus 2b. So we need to square minus 2b squared. So this can be written as the square root of 4b squared, which will turn out to be 2b. This is the answer for w vector. This is the value, the modulus of w vector is equal to 2b. Okay, and the modulus of v vector, I forgot to add this a and s. Okay, so these are the moduli for v vector and w vector. Now let's see what else they are asking. The C part is the time dependence of the angle alpha between the vectors w and v. The time dependence of the angle alpha between these two vectors. Okay. To solve the C part, we need to find the angle alpha between w vector and v vector. Now let's see, v vector is equal to a I cap minus 2bt j cap, and the w vector, the acceleration vector, that is, this is equal to minus 2b j cap. Okay, and we need to find the angle between these two vectors. And in answer, Irodov has given the answer as tan alpha, or alpha is equal to tan inverse something. Okay, so we need to find the tangent of alpha basically, because that's how the answer is given. So sine or cos are not going to work. We need to find tan alpha. Okay, so see, first of all, we can find a value of cos alpha by taking the dot product of these two vectors. If I take w vector dot v vector, what will I get? See, by definition, the dot product of two vectors is defined as the modulus of w vector, the modulus of the first vector, multiplied by the modulus of the second vector, multiplied by cosine alpha, where alpha is the angle between the two vectors. So this is the definition of a dot product. This is how dot product is defined. Okay, so what we can do is, in order to find cos alpha, we can divide both sides by the moduli of these vectors. So what we get over here is w vector dot v vector divided by modulus of w vector into the modulus of v vector. This whole is equal to cosine of alpha. Okay, now see, this will imply that cosine of alpha is equal to w dot v. Now let's substitute the values. W vector is a I cap minus 2bt j cap, and sorry, I've written v vector before. Okay, it doesn't matter. W dot, you take w dot v or you take v dot w, it's not going to change anything. But okay, let me just correct this. Cos alpha is equal to w dot v. W is equal to minus 2b j cap. I have to take the dot product of this with v vector, and v vector is a I cap minus 2b t j cap. This is the value of cos alpha, but I also need to divide this by modulus of w vector and the modulus of v vector. We calculated the these two moduli. Modulus of w vector is simply equal to 2b. You see, I calculated these two values over here, modulus of w vector and the modulus of v vector. So I'm just substituting the values. This is 2b multiplied by the modulus of v vector, that is equal to the square root of a squared plus 4b squared t squared. Okay, this is the value of the modulus of v vector. Now see, this will imply that cos alpha will be equal to first of all, in order to take the dot product in the numerator, we multiply minus 2b j cap with a I cap, but we know that the angle between I cap and j cap, the angle between I cap and j cap will be 90 degree, and the value of cos 90 is 0. So the first term will just become 0. So I don't need to write that. I'll just write a 0 over here. Now the second term will be, in the second term we'll get minus multiplied by minus, which is plus 2 2s are 4 b squared and b squared t, and j cap dot j cap will simply give us the number 1, because the angle between the angle that j vector is making with the j vector itself will be 0, so cos 0 will be 1. So I'll just get a 1 over here. This whole divided by 2b into the square root of a squared plus 4b squared t squared. Okay, so this can be written as 4b squared t divided by 2b the square root of a squared plus 4b squared t squared. Now see, from here this b will cancel out with the square of b, and this 2 will cancel out with this 4, like this. 2 2's are 4. Okay, so this can be written as, finally we can write cos alpha is equal to 2bt divided by the square root of a squared plus 4b squared t squared. Okay, the line is a little bit crooked, but I feel I hope you're understanding it. So the value of cos alpha is equal to 2bt divided by the square root of a square plus 4b square t square. But as I said, they have given the answer in the form of tan alpha and not cos alpha, so we need to find tan alpha, and we know that actually there are two or three different ways we can go about it. What we can do over here is, we know the value of cos alpha. Cos alpha is equal to 2bt divided by the square root of a square plus 4b square t square. So what we can do is we can form a small triangle and then take these values. We know that cosine of theta is equal to base upon hypotenuse, right? So we can draw a small triangle and take the base as set the base to be equal to 2bt and the hypotenuse to be equal to the square root of a square plus 4b square t square. right? But the problem over here will be that if I'm doing that, then I'm restricting my angle theta or alpha. I'm restricting it to be in the first quadrant only. But it is not necessary that it is in the first quadrant, because you will know from your you would know, I hope, from your knowledge of trigonometry, that if cos alpha is positive, which is in our case because the numerator is 2bt and the denominator is clearly positive because there's the square root, and b in the question they have mentioned that b is a positive constant, and time cannot be negative, so t is also positive. So we know that cos alpha is a positive number, but cos alpha can take positive values in the first quadrant and in the fourth quadrant as well. So it's not really right to draw a small triangle with theta or alpha to be acute. I cannot assume initially that theta, that is the angle, this angle alpha or theta is going to be acute. It can be either in the first quadrant or it could be in the fourth quadrant. So I'll use a different method. I mean, you understand? One method was that cos theta is equal to base upon hypotenuse, and then I draw a small triangle with base and hypotenuse, and then I find the perpendicular of that right angle triangle, and then use the formula for tan theta, which is perpendicular upon base. So I can find tan theta that way, but that is not really a correct approach here, I think. Not really 100% correct approach. Okay, so let's see. See, we have found cos alpha. Now I'll be finding the value of sin alpha, and then in the end we can divide sin alpha with cos alpha to get tan alpha. Okay, so see, there's this formula. If I have a vector cross b vector, that is equal to the modulus of a vector into the modulus of b vector multiplied by sine theta, where theta is the angle between the two vectors, and there will be an eta cap, but let's take the modulus of this side also. A cross b. The modulus of a cross b is defined as modulus of a multiplied by the modulus of b multiplied by sine theta. Okay. So let's take the cross product of w vector and v vector. W cross v. W cross v will be written as, now I'm using the formula for the cross product, which is something like this: I cap, j cap, k cap, I cap, j cap, k cap. Then the components of w vector, the x, y and z components of w vector. The x component of w vector is simply 0, the y component is minus 2b, and the z component is also 0. Similarly, here I need to write for v vector the x component of v vector, that is a. The x component for v vector, the x component of v vector is a, its y component is minus 2bt, and the z component is 0. Okay, so this is the value in this will be the value of w cross v as a vector. I will be taking the modulus of this also later on, but let's first find the vector. We know that in order to solve a determinant like this, we need to add a plus sign over here, a minus here, and then a plus again over here. So this can be written as plus I cap 0 minus 2bt and a 0 again. Okay. Yeah, now it's correct. Minus I cap multiplied by a 2 by 2 determinant with its elements as minus 2b, 0, minus 2bt and 0, and then the j component and then the k component can be written like this, and then if I multiply these two terms, I'll get 0 minus 0. Okay, so the final result will simply be 2ab k cap, because the remaining terms are going to 0. So this is the value of w vector cross v vector. But if I take the modulus of this, because you see this is the value of w vector cross v vector. W vector cross v vector is equal to this much, okay? But I need the modulus of this. So taking modulus of both sides, I'll get modulus of w vector cross v vector is equal to the modulus of this thing. And the modulus of this will be simply what? This will simply be equal to this will simply be equal to 2ab, because the modulus of k cap will just be 1, so we are left with 2ab only. So this is the modulus of w vector cross v vector, and the modulus of this thing is equal to 2ab, okay? However, modulus of a vector and the modulus of a, we also need the values of modulus of a vector and the modulus of b vector, which means modulus of w vector and the modulus of v vector. But I have calculated that already, okay? So the modulus of w vector will be the modulus of w vector I have already calculated. That is equal to 2b, and the modulus of v vector will be equal to the square root of a squared plus 4b squared t squared. Okay, this is the modulus of v vector, this is the modulus of w vector. Now see this equation in terms of our notation. This can be written as w vector cross v vector is equal to the modulus of w vector multiplied by the modulus of v vector multiplied by sine theta, or let's say sine alpha, because we are denoting the angle between w vector and v vector as alpha, right? So this is that. Now let's see, w cross v, modulus of w cross v is 2ab. So I'll just write 2ab this is equal to the modulus of w vector and v vector. This is equal to 2b into the square root of a square plus 4b square t square, okay, multiplied by sine alpha. So sine alpha is, so yeah, one more thing, this 2 will cancel out with this 2 and this b will cancel out with this b. So we will be left with sine alpha is equal to a divided by the square root of a squared plus 4b squared t squared, okay? So this is the value of sine alpha. Now we need to find tan alpha, but we know that tan alpha is simply equal to sine alpha divided by cos alpha. And this is the definition of tan alpha. So this will be equal to sine alpha is equal to a divided by the square root of a squared plus 4b squared t squared, this much divided by cos alpha. Do you know the value of cos? Change the division sign into multiplication sign. This will become, so we need to write the value of cos alpha, a divided by the square root of a square plus 4b square t square multiplied by, this will become 1 upon cos alpha. So that is equal to the square root of a square plus 4b square t square, this whole divided by 2bt. Now we know that this whole term will cancel out with this whole term, so we'll just be left with a divided by 2bt. Okay, this whole is equal to a divided by 2bt. So this is the value of tan alpha. So I can write it over here. Let me change the color. Tan alpha is equal to a divided by 2bt. Okay, so alpha will just be the tan inverse of a divided by 2bt. So this is the answer. Let's see. Time dependence of the angle alpha between the vectors w vector and v vector. We have done the c part also. Now d part, the mean velocity vector averaged over the first t seconds of the motion and the modulus of this vector. Okay. We need to find the average value of a v vector averaged over first t seconds. Okay, so let's see. This is the d part. We know that v vector, we have calculated v vector, and the v vector is equal to ai cap minus 2bt j cap. This is the value of v vector, right? Now the average value of v vector's average value. This is defined as the integration of 0 to t v vector dt divided by the integration of 0 to t dt. So this can be written as the integration of 0 to t v vector is equal to ai cap minus 2 bt j cap dt, this whole divided by the integration of 0 to t dt. Okay, so the average value of this velocity vector will come out to be a multiplied by ai cap is a constant, can be taken out of integration sign, so only dt will get integrated, so I'll get a t over here. Similarly, minus 2bj cap are constants, they can be taken out of the integration sign. The integration will affect only the term t, so and this will become t squared over 2, right? And we need to apply the limits also. The upper limit is t, the lower limit is 0. This whole divided by integration of dt. Integration of dt will simply be t, and the upper limit is t and the lower limit is 0. Okay, you see from here this 2 will cancel out with this 2, and this can be written as apply the upper limit, it will get a t I cap minus b t squared j cap. This is the upper limit, and if I'll apply the lower limit is simply 0, so the both the terms will just become 0, so we don't really need to write them, and I'll just write minus 0 over here. This whole divided by upper limit t, lower limit 0. Okay, now yeah, we have to divide the numerator with t, so by doing so we get what? The average value of v, which is denoted in this fashion in the book, so you can use either of the two notations. This will be equal to a I cap minus b t j cap. Okay, this is the average value for over the first t seconds. This is the answer. Thank you for watching.